Hi, my name is Mr. Curlin, and today I'm going to be teaching you about constants of proportionality. So you should either have one of two things. Either you have access to the computer, and you have the access to the notes. You'll need to be on that, because I'll be referring it to two things. Either by page number if you have the workbook, or by slide number if you have the notes. Now, we're going to start with example 1. Today we're learning about how to compare constant proportionalities, which are simply slope, and we'll talk about slope later. But what constant proportionalities tell you is how two things relate. How much is one thing happening for every one of another thing? So, for example, our most famous one is miles per hour. Miles per hour is a constant of proportionality for two reasons. One, it starts at the origin, 0, 0. The reason it starts at the origin is because after you have traveled 60 miles, it tells you that you have been going for 1 hour. That's where we get 60 miles per hour. It's 60 miles per 1 hour. Now, if you're going 120 miles per hour, a lot faster, it means you have gone 120 miles per every 1 hour. So we're going to do the same thing here. But instead of miles, we're going to be using kilometers. So we're going to be European about it, because Europeans use kilometers. Now, what you've seen provided in your slides are two things. You get a table and a graph. Now, in the first graph, they give you a pretty confusing meters and seconds, which is not what we really want to mess with. I want y'all to look at the second graph when we talk about graphs, because they have done all the conversions for us, so it'll be super easy. Let's start with the table, however. On the table, we see two things. We see time and distance. Now, when you get tables, typically, the first row will be time, and the second row will be distance. Now, you'll notice in the example problem when they've written it out, they've actually flipped these two when they start to solve, and that's because our y is actually always on top when we divide. But this is why we need to know that time is generally x, and distance is generally y. Why that's important is because x is the one in this situation. It's the 1 unit. It's the 1 hour. It's the 1 second. It's the 1 unit. The 1 minute in this context. So here we know we go 40 kilometers every 5 miles. Now, how you tell what your constant of proportionality is? Super easy. You just divide them. You divide the bottom number with the y by the top number of the x. So, y is 40, x is 5, y is 120, x is 15, y is 360, x is 45, y is 480, x is 60. So we're going to divide each one. 40 divided by 5 is 8. 120 divided by 15, 8. 360 divided by 45, 8. 4080 divided by 60, also 8. Now that brings up the first rule of proportionality. Constant of proportionality and what you'll learn later, linear functions, need to maintain, I'm going to bring this up so it's a little clearer, need to maintain a constant rate. They need to be going up the same amount every single hour. So let me pause real quick. All right. So now let's talk about a graph. So the graph that we're given, I want you to look at the bottom one, not the top one. So the one on the right under the green thing. So in your book, it will look like, it'll have distance kilometers on this side. So kilometers. And then it'll have minutes at the bottom. So we do our graph. It has 2, 4, 6. So that's really all we need. Now they've drawn their line so that there's a point at 15 at the 1. So they have 20, 40, 60, 80. Now, here's a weird trick you'll need to know for most questions in both the workbook and on the atlas. You'll need to know about intervals. Now, what an interval is a period of time between these two. You'll need to find out the middle of it. Well, you'd ask yourself, what's the middle between 0 and 20? You'd say 10. What's the middle of 20 and 40? You'd say 30. So as you go up, it actually doesn't really go up by 20. It goes up by 10. It's just the 10, some of them, the odd ones, well, not really the odds, but the ones with the first digit as odd, are actually not there. But it's 10, 20, 30, 40, 50, 60, 70, 80. Same down here. 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes, 6 minutes. So we've gone for 6 minutes. Now they have a point at 4 and 60. So they draw a point right here. They also have a point at 6, 90, which is going to be about right here. Kind of getting on my 8's business. So more like right here. 460. Sorry, not a perfect line. But what we basically get is a line that goes like this. Now, in order to find the slope, we need to know how much it's going per unit. Now, we can see that to go from 460 to 680, all we really have to do is count. We need to see how far we're going over and how much we're going up. Now, to figure out how much we're going over, all you have to do is subtract your x's. You have to say, okay, my second x is 6. So this is at what we call x2, but it's just second x. Our first x, x1, is 4. So 6 minus 4 is 2. So we know the change in our x is 2. Now we're going to figure out our change in our y's. Well, that's also pretty easy. All we have to do is we have to do our second y, which is 80, subtract our first y, which is 60, and we'll get 80 minus 60 equals 20. Now, all we have to do is divide them. But remember, it's y divided by x. So we'll want to do our y, the second one, so 20, divided by 2, which is your x. And we'll end up with 10. Now, it's important that we know this is kilometers per minute. So this, did I make a mistake? 80 minus 60. Oh, they go up to 90. My bad, y'all. Scratch that. They go up to 90. So this one instead will be 30. Not bad. I misspoke. So instead of 10, we get 15, because 30 divided by 2 is 15. Small error. But we fixed it. That's why we double check our work. All right. So now we have two numbers. We have 8 kilometers per hour right here, per minute, and 15 kilometers per minute from the graph. And then all we have to do is ask ourselves a simple question. Which is the bigger number, 15 or 10? And 15 is clearly the bigger number, so you know that the plane in the graph actually increases faster, goes faster than the plane on the table. Don't worry about the conversions for today. That's not the point of the lesson. So just worry about the second graph and making sure you know how to get from this point to this point by going over 2 and up 30, because this is 90. And that's how we get those two numbers, and then we just divide the y by the x. In fact, a function, a equation you're about to figure out, or about to learn about, is rise over run. So how much you rise and how much you run. All right, that's example 1. If you want to pause for the moment and go to your try it at the bottom of 122, that's what I want you to work on for the next 5 minutes. All right. So you should have worked on the try it at the bottom of 122 at this point. If you haven't, pause this video again. Keep on going. All right, now let's look at example 2. Taking a second to erase. I could have been doing it. You can keep on working on your try it if you haven't finished it while I erase it. Okay. All right, example 2. So example 2 will either be in your workbook on 123 or on your PowerPoint on slide, what is that going to be? Like, I'm not totally sure. 6 probably, but it looks like this. It has a girl on it at the top. Her name's player 1, Brianna. And a guy at the bottom with the graph. So the graphs on the right represent the rate at which Daniel earns points in his video game. The rate at which Brianna earns points in her video game is represented by the equation y equals 2x, where y is the number of points and x is the time in minutes. First thing we do, because it's easier, is find Brianna's rate. Now, we're told Brianna's rate is represented by the function y equals 2x. Now you might be like, Mr. Curlin, how are we supposed to find the constant of proportionality with such weird functions? It's super easy. In order to find the constant of proportionality, you need to remember the following equation. Y equals m times x. If you have a question where y equals m times x, you know it's automatically proportional for two reasons. The first reason, it has a constant rate, as indicated by m. M is a letter we're going to set equal to our constant of proportionality. We're also going to set this equal to our slope later on. Now, since M is our constant of proportionality, this is proportional for the second reason. There's nothing else. It's just the y equals mx. That means this function is going through 0, 0. A function is only proportional if it does these two things. 1, it goes to the origin. 2, if it has a constant rate. Now, the rate when given equation is super easy. It's just the coefficient. Now, coefficient might be a big, hard new word, but all it means is the number in front of the x. Now, if it's in front and you see no operations between it, so you see no pluses, you need to see no minuses, you see no division, that means automatically it's multiplication. And if it's multiplication, you know that letter is constant of proportionality. Now, if you see a plus or minus instead, this will not be a constant of proportionality, but we'll be talking about that later. Don't worry. All right, so we have y equals mx, where m is the constant of proportionality. So we know automatically that Brianna's rate, the amount she is earning points every minute, is 2. Because that is what replaces the m. See how easy that was? So we know that Brianna is earning 2 points per 1 minute. That's that 1 unit rate we're talking about again. 2 of one thing for 1 of the other. Now, the little bit harder one is Daniel's score. Daniel's score has a graph. And I wish you could see my PowerPoint, y'all. I know it's all white. It's more for it to help me than y'all. So, we know there's 0, 1, 2, 3, 4, 5. We know there's 3, 6, 9, 12. Sorry, there's someone at my door, y'all. I'll be right back. Hey. If we get interrupted a little bit by janitorial staff, I'll have to apologize. So, we have our graph at 3, 1. At 6-2, and I'm not going to really worry about the last one. I'm just going to show you the easy way. All right. So they have another point. You don't really have to worry about it, because to form a line, and form a straight line, you only need to have 2 points, because any 2 point can be connected by one and only one straight line. That's always the rule. All right, so now in order to find the constant of proportionality, we need to find, once again, so this is for Daniel, this is for Brianna. We need to find, once again, how much is going over and how much is going up. Rise over run. So when we look at the graph, we know to go from 0.13, so this is 1.3, to 0.62, we know I am going up, so I'm going over, so 1, so this 1 becomes a 2. So we know my run is 1. So we have a unit rate, that's very useful. But to go from 3 to 6, we actually have to go up 3. 3. So we have 3 divided by 1. 3. Now I'm going to complicate your life a little bit. I'm going to introduce you to a function you need to have memorized. And I'm going to repeat this function throughout the rest of this topic and throughout the next one. Because next topic also has linear functions in it. You need to memorize this. Your M. Here we're calling it our constant proportionality, but it will become our slope as well. Equals y2 minus y1 over x2 minus x1. And you can use this function by knowing y2 is your second y. So it's the y that's more to the right. So this would be your y2, your 2. Your first y will be the one more to the left, y1. It will be the littler number. Right? No, sorry, it will be the 3. Now our x2 is going to be 6. Our x1 is going to be 1. So we can plug this in. We'll get the same answer though. We'll have 6 minus 3 divided by 2 minus 1, which as we got is just 3. So, which is faster? Brianna's score of 2 points per minute or Daniel's of 3 points per minute? Clearly Daniel's. That's how we compare a graph to an equation. That was example 2. Now, before you do your try it, I want you to do example 3. Okay. Example 3. All right. This is still on page 123, y'all. 123. Hey, the graph represents the cost per ounce of a granola cereal. A 15-ounce box of a raisin cereal costs $3.90. Which cereal costs more per ounce? So if in your PowerPoint, you have your PowerPoint, it's simply the next example, graph 3. So in order to solve this, we need to find, the first thing I'm going to do is find what the graph does. Now you can go either way. You can find out what the graph, which per ounce it is better. But once again, we're finding a unit rate. We're finding constant proportionality. We're finding out how much one thing happens for every one of the other. Now this is slightly different, but it's also another very important one in the real world. It is, it's going to be ounces. So how much money do you spend per ounce? Your parents might go to the store and buy meat that's $8 per pound, or chicken that's maybe like $2 per pound. You have to pay $2 for every one of 1 pound you get. So let's look at let's look at the graph first. We have a graph. We are told we have a point at 1, 2, 3. So we have a point at 4 and 5. So they're rude to us, y'all. So we have a point at 10, 2.5. It's about right here. And a point at 20, 5, 10, 15, 20. So we know we have another point right here at 520. Right there. And we're going to get a laugh. Sorry, I'm hand drawing this so it's not perfectly straight. 10, 2. Oh, this is at 2.5 anyway. That's the why it's not straight. So about right there. We get a graph that looks about like this. But we're told there are 2 points. That's what we care about. 10, 2.5, and 25. So in order to solve this, we're going to use our handy equation we just learned. We learned that m equals the difference in the y's, so y2 minus y1. That's all it means by difference in the y's. The second y, subtract the first y, over the difference in x's. x2 minus x1. Now we simply have to plug in our numbers. So remember, y2 just means our second y. So we ask yourself, going from left to right, which is the second y that comes up? Well, this is the first y, because remember, they're always xy, xy. This is some review from 7th grade. We know my second y is 5, because it comes farther to the right. So we can immediately replace that y2 with 5. Now we ask yourself what the first y is. Well, the first y is 2.5. because it's the y that comes closer to the left. So just like you read a book, you read the graph the same way, going from left to right. 5 minus 2.5. Then we have our x2. Well, x2 pairs up with the second y, so it's really easy to find at this point. It's that one, which is 20. And we subtract our first x, which is goes with our x1, minus 10. So 5 minus 2.5 is 2.5. 20 minus 10 is 10. We do some quick division, and we do 2.5 divided by 10. We will get $0.25. So it's 25 cents for every ounce. Sorry, my dollar sign makes it look like a 10. So this is $0.25 per 1 ounce. So we know that for every ounce of one cereal, you're having to pay a quarter, 25 cents. So now all we have to do is look at the second part, the word problem, and see how much per ounce it is as well. And it requires, you guessed it, division. Almost every single one of these problems when dealing with constant proportionality will be division. So we have 15 ounces for every $3.90. Now, since we have $15 for every $3.90, we need to look at our graph and see which one's going to be the y and which one's going to be the x. So we look at the graph and see that the cost is the y. So we know my $3.90 is my y. We look at the graph and see the bottom axis, our x-axis, is ounces. So we know our x is going to be ounces. And then we're going to do exactly what we did with the table. We do y divided by x. And this will get us our constant of proportionality. 390 divided by 15. And what you'll end up getting is 25 cents. You'll get, 26 cents for every 1 ounce. So this is the second, it's the word problem. So then all you have to ask yourself is which is a bigger number to tell which is the better deal. If the bigger, in money, the bigger number isn't actually the better number, it's the worst number. Because you don't want to pay 26 per ounce if you have available if you have 25 cents an ounce, because overall one will be more expensive. This is just what your parents do when they go to a gas station. They'll see on a gas station that something costs, let's say, $5 per gallon. That's a little bit high. That's California rates. $2.40 per gallon. That means that for every 1 gallon they buy, they have to pay $2.40. It's not telling you that gallon costs $2.40. That's not how much you're paying, because nobody buys just 1 gallon. You're buying multiple gallons at that price. So per gallon you pay $2.40. So if you buy 10 gallons, you pay $24. So you use these constants of proportionality every single day, because often the origin is 0, 0. If you go to a gas station and you buy $0 in gas, how much will you pay? Or if you buy 0 gallons, how much will you pay? $0. Make sense? If you buy 0 cereal, of course you'll pay nothing. But then once you buy 5 ounces of cereal, suddenly you start having to paying a little bit more. And knowing which is the lower number will help you get the better deal. That's all from me, Mr. Curlin. Hope you have a great day. Either do the Math Excel, but if you have the workbook, we're also going to do the workbook on page 125 with number 6, number 7, and number 8. So if you want to try those 3 problems for me or work on the Math Excel that has been assigned to you, that would be perfect. Thank you so much. Have a wonderful day. My name is Mr. Curlin, and I might have taught some of y'all last year. So have a good one.